Have you ever wanted to ethically, and I mean only ethically, grab someone's hash using a password cracking attack? Have you ever wondered how other tools are able to do so? Well, it's time for us to up our skills. It's Novice here, and in this short series, we'll learn how to build an AS-REQ roasting tool. Now, before creating this tool, we'll have to dig a little deeper into Kerberos to find out how it works. I know that I've given a brief overview before, but today we're going to be going into some of the technical parts of Kerberos and why they are important for the tool. This will not only deepen our understanding of how an AS-REQ roasting attack really works, but this project can work to show employers that you're willing to really dig deep and that you can build tools that can bolster the security of any environment. Now, to start, you would think I'll jump right into talking about Kerberos tickets, but we do have to speak about something known as ASN1. Now, this is a schema that's used to build all the messages that are transmitted between the client and the KDC. Now, ASN1 is a schema language. Now, ASN1 is simply meant to define a structure. Not only that, within ASN1, there's something known as a field. Now, fields are comprised of the following. Fields have a name, a type, a position, and that's it. Now, fields are encoded in whatever order that they're supplied into it, but I'll go into that a little bit later. And then sometimes with fields, some can be mandatory or optional. Now, this is going to be really important when dealing with AS-REQ roasting, because you're going to see me not include a lot of fields in this tool because some are not optional for what we're trying to do, or some are not mandatory for what we're trying to do. Now, when we continue to look forward more deeply into ASN1, there's also something known as a sequence. Now, a sequence is simply a collection of fields. Now, most of the messages that we're going to play around with, including AS-REQ, AS-REP, something known as Kerberos, ticket, encrypted data, so on and so forth, are actually sequences. Now, not only that, some of the fields within these sequences are also sequences themselves. So when you think about that, just try to think of a function within another function. Now, moving on to tags and constraints. With ASN1, there's something known as a tag. Now, tags are simply used to inform the KDC of what type of message they're receiving. So when you think of a tag, generally just think of like a name tag. Like, oh, my name is John, I work here. Now, using a tag just defines what type of thing, message, or information is being relayed, in this case to the KDC. For example, and I'll go over this a little more in our actual code, our tag for our AS-REQ message is actually going to tell the KDC that, yo, I am an AS-REQ message based on this. Now, not only that, tags are also broken up into parts itself. So tags are broken up into classes, format, and a number. Now, the class of a tag essentially defines the type of message that is going across. Now, when I say that, in Kerberos, there's one specific class that is used, and it's known as context specific. That is essentially the only tag that we'll be using for most of the tags within sequences. Next, we'll speak about the format of a tag. Now, there are two types of formats. Essentially, these are primitive and then constructed. Now, constructed is used in the scenario I listed above. So when there's a sequence within another sequence, it usually uses something like a constructed tag instead of a primitive tag, because a primitive tag is something such as an integer, Boolean, just simple types of information within a message. And then next is an actual number of a tag. Now, this number is what gives the information or details about a tag. Now, in many cases, the numbers are, well, in all cases, the numbers are related to a certain thing. In my previous example with AS-REQ, the number that we're going to use is actually going to tell the KDC that, yes, this is an AS-REQ message. Now, coming down to constraints, constraints are usually just used to restrict allowed values. So say, for instance, that we have something that's tagged with as an integer with constraints of 5 to 10. Now, this essentially just means that the integers that are going to be allowed to be used in this specific tag are going to be 5 to 10. Now, that just limits limits what you're actually using as values so that you can determine what is correct. Not only that, it doesn't only deal with numbers, it can deal with the alphabet, it can deal with sizes, single values, ranges, whatever you can think of. And now finally, I kind of just want us to go over some of the message types that we're going to see, especially in this project. So the top 3, or the most important 3 that I'll be going over, are AS-REQ, AS-REP, and curve error. Now, AS-REQ is the first and most important, as it gets us the information to do everything else. Now in AS-REQ, there are 11 total fields within the AS-REQ sequence. These fields are PVNO, I forgot what that stands for. Next is the message type, PA data, request body. Oh, I'm sorry. Okay, I said there are 11 fields. There are actually 4 fields, but then within the request body, there are 11 fields. Now the request body and PA data are both actually sequences within the AS-REQ sequence. So in PA data, there are 2 fields within it, PA data type and then PA data value. Within the request body, that has the 11 fields that I was alluding to prior. And these fields are the KDC options, the client name, the realm, the service name, from, till, R time, nonce, E type, which is encryption type, addresses, encryption authorization data, and finally additional tickets. Now we're not going to use all of these in our actual tool, but I'll show that to you once we get there. Now, once we actually get an AS-REQ message back, we're going to be looking for 6 fields. Now this is going to be as follows. It's going to be PVNO. Sorry, I really don't remember what that stands for. Then we have message type, PA data, client realm, client name, ticket, and then the encrypted part. And then Kerberos error is also very important, because if something goes wrong, this is where we're going to get our error message from, so that we can know either, oh, this user might have pre-authentication enabled, therefore they're not vulnerable to AS-REQ browsing attacks. Or another possibility is that your encryption type is not found on that KDC. It can return an error message that shows you that. Now there's multiple different error messages as well, but those are the top 2 I can think of off the top of my head. So in Kerberos error, we also have PVNO, not sure what that means, message type, C time, CUSEC, S time, SUSEC, error code, which is very important for us finding the error, C realm, C name, realm, S name, E text, and E data. Now there's going to be more sequences that are in use in this project, but I'll break them down as we go through, as today I kind of just wanted to give an overview of what ASN1 is and how it actually applies to Kerberos tickets. Now with that knowledge, once we go over to our coding side, I'll still explain it there, but you'll have some sort of mental image as to why these are important and why things have to be built out the way that they have to be built out. Now with that being said, that's essentially the end of today's video. Hopefully you guys enjoyed it. I've been working on this one for a little bit, so I'm hoping you guys will get a chance to get your hands dirty, be able to build out this tool, and hopefully you just enjoy. This honestly taught me a lot more about Kerberos than I ever expected to know, and so that was a fun experience. Not only that, it gave me a much better idea of how an AS-REQ browsing attack looks like, and in the future probably a Kerberos attack, but that's probably going to be added on to this project that we have to complete now. But with that, that's the end of the video. If you guys like the video, go ahead, hit that like button. And if you guys would do me a favor, go ahead and subscribe. That's what I'm doing here. If you might want to see more in the future, just go ahead and hit that subscribe button. And for those that didn't like the video, please let me know why. I'm open to learning, trying to get better, and I do need your opinions to do so. But with that out of the way, that's all from me. So, NOVICE out. Peace.